Alright, everybody in their places. You guys ready on acid?
Ready on acid.
Ready in the blender?
Ready in the blender.
Tenfold. Go ahead and swap me the acid.
Let's get it Fracsim. Hotel wake up call got me getting up.
Today I'd like to go over simulating, powering, and measuring current from transmitters, all with the Fracsim. This is possible because the meter will simulate thermocouple over RTD, measure current, and supply 24 volts. So I'll go through how to set all that up with a RTD transmitter. So this is just the basic RTD transmitter I have here. Well, RTD or thermocouple, depending on how it's set up. And I just like to go over how it's all marked first. So you'll see, I'll put a picture on later, but there's a little symbol right there, and that is the symbol for an RTD. Just below it is the symbol for a thermocouple, and on here they actually show you how to hook up everything. If you don't even have the manual, you can actually just reference this drawing on how to hook everything up, and they've got that RTD symbol right there. You see how there's one wire, or one line going down to here, another line going to here, one going to here and one going to here. Now see how it's marked, how the primary is straight across, and then there's a 3 over here. That means that if you're using a 3 wire, you hook up the 3rd wire there. This last one that's dashed is the if you're using a 4 wire RTD. Thermocouple is pretty simple. Looks like you just hook up between there and there, positive being there, negative there. And of course, everybody knows that the red happens to be negative on most thermocouples. So what I've done is I've already taken a transmitter and I've hooked up everything here. I've got the way the Fracsim works, it only simulates RTD, 2-wire RTD, so I've had to actually jumper, because this transmitter is set up as 4-wire. You just jumper the 3rd and 4th wire. You just jumper those together and then simulate on the primary. And for the most part that works. You're going to get a little bit of inaccuracy due to line drop, but for the most part in the service industry, our temperature transmitters are only used over a short distance, so that lead resistance is negligible, or the error from lead resistance is negligible. And I've hooked up power, of course, to the what's labeled positive and ground, or I've hooked up 2 leads that we're going to hook up to power. So if you look at the back of the Fracsim, of course, we'll talk about how to make those connections. So if you've watched the testing a transmitter video, it's pretty similar. Basically, we're going to have 24 volts. So 24 volts right there coming into pin 1. And then on pin 2, the return, we're going to go into the measure pin. And because ground is common between measure and the supply, that'll provide our 4 to 20 loop. Now in terms of the RTD sim, we're going to hook up, like I said, one of these here that's hooked up to 4 and 5 to RTD sim, which is right there. You can see RTD sim, and the other one just to either one of the grounds. It doesn't matter. Ground is common. The thing to keep in mind is doing this, you can only, because the grounds are common on everything, you can only do this on galvanically isolated transmitters. They're galvanically isolated between the input and the output side. If they're not, then you end up with it not working correctly. You can still use, you could use a Fracsim and a bench power supply, or a Fracsim and another meter to measure the current, or 2 Fraxims, but you would have to use 2 different devices. An example of a transmitter I've seen that's not galvanically isolated are these Danfoss ones. They are not galvanically isolated between the input and the output, and they do not work correctly for this. So I'm just going to go ahead get everything all hooked up. So like we said, we're going to put 24 volts over here onto the white pin. We're going to measure the return just like we did with a regular transmitter, pressure transmitter, and then a ground over here. The resistance sim is not polarity sensitive, so you can hook that up any direction. And find our resistance or RTD sim pin. There we go. So everything should be hooked up there. Turn on my meter. First I'm going to go and turn on the 24 volts F5, F3, and that's the power of the transmitter. And back out of the settings screen. Now if I just want to measure current, we'll see a value there, and then it's actually in error state right now, so it's going to go to 22 milliamps approximately. That's because we're not simulating RTD right now. So if I were to back out and go to simulate, I'm going to pick RTD. Now this is important, you get the correct RTD type. The first part is the base resistance, and the second part is the that linearization, or the curve or line. So 100 ohm platinum RTD at 385, that's what we're using. So right now it's simulating at simulating a temperature of 0, which is 100 ohms, so we just discussed, and we get 8.76. So I'm going to try to find, I'm not too sure what this transducer is set up for, so I'm actually just going to try to find out how it is set up. So I'm going to put in negative 25. See here, it's got a little bit of averaging, but dropping down 6.36, so lower than that. Obviously our target would be 4 to find out what its 0 is. So I'm going to try negative 50. Yeah, 4.04. So negative 50, and our transmitter is doing 4.04 milliamps. So obviously the 0 point on this transmitter is minus 50. So let's try to find the top end now. We're just going to put in 100. Seems like a nice round number somebody would use. And 18.08. So not quite. Let's try 125. Oh, obviously I went too high. We're 20.43. Let's try 120. There we go. So our transmitter here is set up for 4 milliamps is equal to minus 50, and 20 milliamps is equal to 120. And from everything we're doing here, it seems like it's working correctly. You could even put it on a step just to watch it go throughout the range, or a sweep, just to see, to make sure as it's going through everything's changing nice and uniformly. But for the most part, transmitters don't fail in one part of the range. They'll either completely fail so that they're not working at all. But still not a bad idea to test it, all of it.